Okay, so here we have an absolute value equation. We've got some things going on inside the absolute value sign. We've got some things going on outside the absolute value sign. So first we're going to subtract 13 from both sides. Next we're going to divide both sides by -3. So we have the absolute value of 2z plus 9 equals 1. So at this point, split it into two separate equations. We're going to write one as 2z plus 9 equals 1, and the other as 2z plus 9 equals -1. Subtract 9, you get 2z equals -10. Divide by 2, divide by 2, z equals -5. Same thing over here. Subtract 9, 2z equals -8. Divide by 2, divide by 2, z equals -4. Now this process also applies to inequalities with absolute values in them. For example, the absolute value of 2d plus 3 equals 21. Subtract 3 from both sides. The absolute value of 2d equals 18. We're going to split it in two again. 2d equals 18. 2d equals -18. Divide by 2. d equals 9. Divide by 2. d equals -9. So if we go back and we make this whole thing an inequality, undo all the work we've just done, and instead make it greater than 21. Process stays the same. Subtract 3 from both sides. The absolute value of 2d is greater than 18. This is where the only change comes in. When we split it into two, we're going to do 2d greater than 18. That's the same. But the other one's going to be 2d less than -18. And then we continue from there. Divide by 2, divide by 2. d is greater than 9. Divide by 2, divide by 2. d is less than -9. And the only tricky part here is figuring out whether this is an and or an or inequality. So we check to see if there's a value that can satisfy both of these inequalities. There isn't, so this is an or inequality. d is greater than 9 or d is less than -9. And the graph would look like this. We have line here, 0, -9, 9, open circle that way, open circle that way.